Okay, so let's start. So first of all, do you remember what is convolution? What is CNN? Okay, convolution is nothing. It's just a mathematical operation, and we are doing it just to extract some information or some representations from the input data. That can be your text, your image, or audio files, or anything. So CNN is convolution neural network, and what we want to do is we want to apply a filter on the input data. And what input data looks like? It looks like a set of values that can be your two-dimensional value, three-dimensional values, one-dimensional value. So that is your input data definitely, and that would be in the numeric form. So you just give input, you just have a set of values, maybe in a array form, or maybe in a matrix form, or maybe in a cube form. Okay, so these kinds of input data you have, and you apply a filter. So filter is nothing, it's just a small subset, and that small subset of values, and that you apply over each and every position in the input data, and you get some representation out of it. And simply put, for example, you want to highlight some middle portion in the image, or so your filter decides what kind of representation you want as output from that image, or maybe a text, or maybe any other data that you are giving as input. So idea behind CNN is you just apply a filter on the image, and when image or maybe text. So whenever you apply filter, you just want a specific kind of output or specific kind of representation out of that. And that is the whole idea behind convolution. So simply in one dimensional, instead of doing that in a multiple 2 by 3 or 3 by 4 filters kind of thing. So this is just a simple example. This is your input data. This can be your maybe this is your feature vector right now, and it is of dimension 12 cross 1, and you are applying filter weight, which is 1 cross 1. So the process would be you multiply these two, and you get your first output. Then you uh, move it to the right, move your filter to the right, and then you apply 6 to it, you filter to it, and you get something. And this process goes on and on. Okay, so this process goes on until you get your final. So this output is called feature map, input is your feature vector, and this is your filter weight. Okay, so this is a simple example of one. So instead of passing input in the form of 2D array, we are just having a vector as input, and this one is important. So you are having just filter size, which is of 1 cross 1. So let's have a look at 2 cross 1. So this is simple example where you have a 2 cross 1 vector, and how you apply convolution to it is you multiply 9 by 3, you multiply 7 by 6, and you add these values. So whenever you add, you will get 69. So after applying this whole convolution, 2 cross 1 convolution to your input feature vector, you will get this first value, the 69. Similarly, you move after doing this, what you do is you move your filter slightly to the right, and next position that you apply your convolution is 3 over here and 6 over here, and you multiply 7 by 3, you multiply 2 by 6, and whatever you get, you add it, and you get 33 as your output. So input was so because filter size is 2 cross 1 and input was 12 cross 1. Right now you can see the dimension of output feature map is reduced from 12 cross 1 to 11 cross 1. Earlier it was same because filter size was the same, but right now it is reduced. So as we keep on increasing the filter size, as we keep on increasing the dimension of filter, we will get this feature map dimension would reduce as we keep on increasing this to as we keep on increasing this filter size. So the last output you get would be over here. This would be 3 and 6. So this 8 would be multiplied by 3, 4 would be multiplied by 6, and you add these and you get 48. So last value you get is 48, but you are not sliding it slightly towards left, because you don't have any value over here to multiply with the 6. So because you have studied this already, so what we do in this case, we just pad our output so as to so that our feature map size does not reduce, and it would be same as our input. Okay, so this is the idea. Similarly, if you have a 3 cross 1 filter, so you keep on multiplying each and every value, and you add all those values and you get number as output, final output. Similarly, you slide it slightly towards left and you multiply it with 1, 3 and 6, and you get 37 as your, and so on. So this process repeats until last value, and last value would be over here, and these values are multiplied, and so this is a convolution operation, 1D convolution operation. Okay, so similar thing happens with the text. I'll tell you how this works with the text, because we have word embeddings as input and we apply 1D filters to them and we get our output. Now let's have a look at padding. So because we don't want feature map output to reduce as we keep on increasing the filter size that we have, so we apply padding. So that is what we do. So we add zeros to increase the size of feature map. Now if it was a 12 cross 1 12 cross 1 input image, and this was 3 cross 1, so n minus f plus 1, so that would be my output image. So that would be 12 minus 3 plus 1, that would be 10. So output would be 10 cross 1. So what if I pad it with 1 0? So if p is equals to 1, so that means I pad 0 over here as well as I pad 0 over here. So two paddings are done at simultaneously. Okay, so I pad with two zeros, and now my input n would be changed from 12 to 14, and now I can say it. So this would change from 14 minus 3 plus 1, so that would be 12. Now output size would be 12 cross 1. So I want to keep the output same as my input, that's why I have padded it with the zeros. All right, so this is the process of padding. Now, striding is shifting right to S units. Now, striding is what? The example that we have discussed over here is we were just shifting our filter one step to the right. Okay, so in striding, what happens is, suppose this was my image, sorry, text, input feature vector. So this was 1, 2, 3, 4, 5, and my filter was 1, 2. So next position would be this 1, 2, and next position would be this 1, 1 and 2. So so suppose this was 1 and 2. So up till here, so I'm striding it, shifting it one step to the right, so that is s is equals to 1. Now that depends upon me. If I feel like all the information is extracted, so what I'll do is I keep sorry, stride was 1, so I make stride is equals to 2. Now just in case if I do stride is equals to 2, in that case what will happen is 1, 2, 3. So instead of, so first would start from here 1 2, second would start from here, rather than multiplying it with the 2, this 1 with 2. So we will start at, we will shift 2 twice position to the right. Okay, and we leave this 2 and we multiply 3 with 1 instead of multiplying 2 with 1 over here. So we will multiply this with 1. So this is called striding. So padding and striding are these two concepts that we need to learn whenever we are talking about convolution operation. Now after that comes pooling. So pooling is nothing, whatever we get as output. So this was my output feature map. So I will apply max pooling, I will get maximum out of these vectors, and if I apply min pooling, something like that. Most of the time it's min, average, so many other are there. So pooling is there. Then up till now we have discussed convolution operation, basically 1D convolution operation. So this is simple example. So input was n, so n cross 1, basically 12 cross 1 was my input. Filter was 3 cross 1 and padding was 0 suppose and striding was 3. So output would definitely be 4. So that this is the formula for that. So 12 minus 3, 3 plus uh, uh, 3 plus 0, 2 into 0 by 3. 3 is the stride plus 1. So 3 is the stride means you are shifting 3 times to the right. So you are applying filter over here. You next position you are applying from here. So shifting it 3 positions to the right. So this is a simple example. Uh, Now this is the architecture. So simple architecture, first of all you apply convolution, you apply pooling, then you can apply activation. Basically you apply activation to whole of these. Now one thing if you might have remember is only hidden layer, that is your feature, sorry, your filter. So your filter would be having parameters to learning parameters. So all the learning parameters are these plus the activation that you are applying over here. And pooling, your max pooling will not be having any parameters to learn. You are just selecting the maximum out of all the positions. You are just selecting the maximum value, so it is not trainable layer. So pooling is not, you are not training it basically. As per learning weight, so only your hidden layer, that means your convolution layer with filter, basically your weights of your filter that you are learning. So those are your parameters, and another is your activation function that you are applying to while convoluting. So this is your first convolution, second multiple convolution. So you apply convolution, pooling, then again this process is repeated, and finally you apply softmax or dense layer. Basically dense layer first and then softmax. So this is your whole architecture. So any doubts up till now? Okay. Okay. So let's have a look at CNN in text. So this was your input embedding, and you might be having multiple features, multiple embedded vectors, and what you are doing is you are creating in one dimension vector out of it, and you are just applying convolution, pooling, and then softmax. This is your softmax as your output. So this is for text. You just have your embedding, two-dimension embedding, you just convert it into one dimension, and then you are applying your softmax. uh, what about suppose you want to train two words at a time, 2 grams you have. So the advantage of this 1D CNN over other models is, suppose you have two words. This was cat sitting and this was dog resting. Basically, we are talking about an animal in first word. We are talking about animal in first word, and we are also talking like it's doing something. Maybe it's sitting. Resting is also sitting, and maybe it is also sitting. Okay, so somewhat similar. So these two words are similar. These two words are similar. I want to talk about 2 grams. Okay, so it should generate similar kind of representation, right? So these two words, if I talk about 2 grams, so these two words are there, and I apply a convolution filter, it will give me same kind of value, similar kind of value. So this is the advantage. Like it considers two words that may be different. Cat is different, dog is different, although they both are animals. And whenever I'm training something using word to vec, I should always get vectors which are similar, should have similar kind of weights, and vectors which are entirely different should have values. For example, words which are entirely different or opposite should have different kind of weights. So this thing is retained by 1D convolution neural network. So if you talk about 2 grams, 3 grams, 4 grams, so if you are considering multiple words at a time, so it will definitely give the representations which are similar after training. So this is the advantage of 1D convolution neural networks. So this is, they are showing this as example. So they are generating, and out of which they will select the max value, max pooling, and then so this 1D can be extended to 3 grams, 4 grams, and so on. So that's it for today. So any doubts up till here in 1D CNN? Okay, I might have downloaded the research paper. I want to show to you. This is a survey paper where they have mentioned about the 1D CNN. So this is the architecture diagram of one-dimensional CNN. So research paper is 1D convolution neural network and applications. So So this is 2D. First of all, they are describing about uh, the how 2D CNNs work. So to start with popularity, they are just simply telling what CNN, and then they are just describing about 1D CNN. So this is really good research paper. So yes, so this is the architecture diagram. So here. Okay. So as in the Con 2D, CNN, the input is a passive layer that receives raw 1D signal, and output layer is an MLP layer with the number of neurons equal to number of classes. So that is softmax. So there are three consecutive CNN layers of 1D CNN so are represented. So these three are one dimension. So first is exactly same, and these three CNN layers are 1D, and 1D filter kernels have size 3. 1D filter kernels, in the sense one dimensional filter kernels are there, and the subsampling factor is 2, where the kn neuron subsampling factor means you are just subsampling, basically pooling. So you are just max pooling it, and sequence of convolutions, the sum of which is passed through activation function. So this is indeed the main difference between 1D and 2D CNN, where 1D arrays replace 2D matrices for both kernels as well as feature maps. So this is important line. So that this is the main difference between 1D and 2D CNNs, where 1D arrays replace 2D matrices for both kernels. Kernel means your filter, and feature map means your output, whatever representation is it is generating, of course. So because your filter is of 3 cross 1, 4 cross 1, 5 cross 1, like this, because it is one dimension, your filter is one dimension, so definitely it will give you output which is one dimension. Okay, so this is the idea behind 1D CNN. So that's it.